Then the topics. So this is an overview of all the topics that we have gone through this year, mainly only the theory ones. Let's put some light on, that should help a little bit with the visualization. So these are theory ones. A few of them I've switched to from practical to theory, etc. But we're looking at the stuff that might be relevant for your exam. A tiny bit of clarifications were added here as well, but not that much. So to start, values, variables, pointers, and lifetimes. I'll try to go through this reasonably quick because I'm not having that much time. A lot to go through. There's 95 slides, my system says. So, values and variables. So, unlike math, in computing, when we have a variable, that is actually a storage location where we actually keep that value there. Whereas a value is 2 or 5 or etc. and it doesn't matter where you store it, it's the same value. The storage location is different. And it's helpful to understand that when you have a variable, you're talking about storage locations. And especially when you have a variable, so one that can change. If you have a final variable, or Kotlin calls it a val or value, then that change thing goes away, not because it's not a storage location, but because it is forbidden to change. So at that point, you can actually treat it as if it was a value. With one additional proviso, that is that your actual program cannot, so that if things inside your value can change, that is still changeable. Whereas in math, a value is that and it can never change. So if you do not have an immutable type, then still the insides of your value can still change. They basically, a compound value in Java or Kotlin is a collection of storage locations, effectively. It exposes named storage locations as the inside of that thing. So that is how that works. So when you have a variable or a name in programming, you have a limited lifetime. It's limited by the scope, and in this case we call that a lexical scope. So look at your program and see, okay, which is the scope, which is the set of curlies in which this has been defined. And outside that block, the name just does not exist. Or it falls back to another thing with the same name. And we call, if you do that, that's called shadowing. Not a very good idea in general. Sometimes it's okay, but you need to be very careful that it doesn't become confusing. But so a name that falls out of scope disappears. The value attached to that may not. There's another slight point that there is also something called temporary conceptually. So if you have a function and it returns a value and then you're adding 1 to that, that return value gets kind of a temporary storage location, and as long as you're in that expression, you're still using that location is still there. It is very temporary. As soon as you have done the addition, it's gone. Let's not go over the mechanisms by which that works, but that's what it's doing. So when you have your values, they live basically as long as there is a storage location for them. In particular, if you have a garbage collected one, there's 2 storage locations. Effectively, we have the reference that points to the actual location of that object. As long as there is something pointing to that thing, it says, okay, there is a way of getting at it, therefore it lives. And if you do not have pointers or references, you basically only have one storage location. So that's where pointers come in, and they are very important when you look at objects and instances. So a Java reference or Kotlin reference is effectively a pointer underwater. It hides away the fact that it's a memory address, and on the JVM it isn't necessarily a memory address. That's all up to the JVM. You cannot get at the raw number, but it is a way of looking at a particular space in memory where that particular object has been defined. And you want to make sure that, of course, it points to a valid location. So a reference is that, and then null is a special value that makes it, that effectively cheats a little bit on the definition, because if you compare with null, you are comparing with the pointer value rather than anything else. But because null is only useful in that context, it doesn't matter. So references and pointers allow you to say, okay, there's multiple names for the same value, for the same memory location in which that value has been defined. So there's multiple ways of pointing at that. So multiple attributes could hold the reference to the same object. You can pass it along, etc. And when you're looking at UIs, this is really important, because if you want to, say, get something out of a text box, you want to go that text box with that text that is displayed there. You don't want to make a copy of it and then you update the text and it doesn't work, or it gets an empty text field and you can't get the text out of it. No, you want that particular one, you want it to be updated in the UI.